Hello, class. I wanted to go ahead and actually do a live session with you. And if someone shows up, then that'll be wonderful. But if not, I'm going to record this session and work these problems out so you guys can watch them whenever you'd like. But I'm going to actually go through the midterm exam. Now, this is just like your midterm exam that you're going to have. The numbers will be different, but this is a version of that exam, and you can see that this is one of the versions from the midterm exam. Okay, so let me go ahead and go through this. So this first problem here, what I'm going to do in order to simplify it is that 81, I know that 81 is equal to 3 to the 4th power. So I'm going to rewrite that as 3 to the 4th to the 3/4 power. And a power raised to a power ends up reducing or ends up multiplying. And so I'd get 3 to the 4th times 3/4, which is going to give me 3 to the 3rd. And so my answer is going to be 27. I don't want that to be mistaken for part of the answer. So the answer is 27. Now, one of the things that I'm going to... I already posted up this not this worked out thing, but I posted up the this worksheet, and at the end of the worksheet there are answers. So if you guys want to be able to confirm, the answers are at the bottom, and you can see that there's the answer. It in fact was 27, but I'm going to work them out so you can see, and then you can confirm the answers in the back. Okay, now this next example, it's to the 4th root, and so what I need to think about is numbers that are 4th roots. And so 2 to the 4th is 16, and 16 times 5 is 80. So I'm going to go 2 to the 4th times 5, and then I'm going to go y to the 4th times y to the 4th times y to the 3rd, and that's going to all be under the 4th root. Well, everything that has the same power as the root is going to come out as an individual number. So 2 to the 4th, the 4th root of that is going to give me 2, and then I'm going to have a y and a y. And then inside of the root, what's left is 5y to the 3rd. So the answer ends up being 2y squared, the 4th root of 5y to the 3rd. Okay? And again, I just happen to know that 80 was 16 times 5. Obviously, for some of you, that'll take a little bit of practice, but you're allowed to use a calculator, so it should be something that you can do. Okay, for number 3, in order to be able to do number 3, our root, in order to simplify it, has to be the same. So, since we're doing square roots, I'm going to go, all right, 3x squared, and then I'm going to go 16 times 5 times x, minus, I'm going to go 9 times 5 times x squared times x squared times x, and that's under the square root. So then that first one is going to be square root of 16 is 4. So then 3 times 4 is 12x squared, square root of 5x. And then in the other one, the square root of 9 is 3. And then I have 2x squared, so that's going to be x times x, which will give me x squared. And then what's left inside is square root of 5x. Now, since these guys are the same, I can combine these terms. So I'm going to go 12x squared minus 3x squared is going to yield 9x squared square root of 5x. And then this is this answer. Okay, now to do the next one. I'm going to have radical 10 times 5 radical 20. So what that's going to end up being is when I distribute, the way I try to do this problem is this way. I'll take that first number and multiply it by the second parentheses. And then the second number from the first parentheses times the second parentheses. And this is just called the distribution method. And so what I'm going to get here is 5 radical 20 minus 3 radical 10 plus 15 radical 2 minus 9. And square root of 20 is square root of 4 times square root of 5. So square root of 4 is 2. So 5 times 2 is 10. Square root of 5 minus 3 radical 10 plus 15 radical 2 minus 9. And that should be our answer for this problem. We can't simplify any further because the roots are not the same. So that's what I got for number 4. So let's make sure. Let's go back and see if number 4 is in fact some complicated little answer. And we can see that number 4 is 4 terms just like I had. I'm not trying to make you dizzy, sorry. All right, so for this next one, in order to rationalize the denominator, what we need to do is multiply by the conjugate. So multiplying by the conjugate, I'm going to take the same numbers that are in the denominator, but I'm going to, instead of having a minus sign in between, I'm going to have a plus. And then I'm going to take that same number and multiply the top by that. So top and bottom get multiplied by the same number, so what's going to end up happening is I'm going to get a negative 21 minus 6 radical 5. And then in the denominator, these end up being like a difference of square. So a plus b times a minus b is equal to a squared minus b squared. So my a in this case is 7. So 7 squared is 49. And my b squared is 2 radical 5. So 2 radical 5 squared is going to be 4 times 5, which is 20. So I'm going to get 20. And so I'm going to end up getting negative 21 minus 6 radical 5 over 29. That's not what I want. So there's that answer for number 5. Okay, so now going on to number 6. So this problem is actually pretty nice because it's already, the root is already isolated. I can square both sides. So what I'm going to do, my very first step in this problem is to square this side and then square this side. So that's going to give me a negative w plus 23 is going to be equal to that side expanded, which will give me this. And then I'm going to bring everything to one side to try and simplify this. So I'm going to get 0 is equal to w squared minus 5w minus 23 minus 9 is a negative 14. And that ends up being factorable. So I'm going to get, not x, I'm going to get w minus 7 and w plus 2 is equal to 0. So then w is equal to 7 or w is equal to a negative 2. Well, we need to check and see if that is in fact accurate in our original equation. So getting rid of the squares here, going back to the original, if I plug in 7 into this, this is going to be 7 minus 3, which is 4 on that side. And on the other side, I get a negative 7 plus 23 rooted would give me 16, which is in fact 4. So this one for sure works. That's for sure an answer. Now what we need to do is check the other one. And the other one ends up being what's called extraneous. And the reason it's extraneous is because I'm going to get a negative 2 minus 3, which is a negative 5. But if we plug that negative number in, we're going to end up getting negative 2 plus 23, which is the square root of 25, which is positive 5, not negative 5. So this answer does not work. So whenever you have these rooted problems where you square, there is the potential for extraneous answers, and you need to check for those in order to be able to solve it. Okay? All right. So number 7, standard form for complex numbers is a plus bi or a minus bi. And so when we distribute this problem out, I'm going to get 12 minus 10i minus 36i plus 30i squared. Well, that's going to give us 12 minus 46i, and then that's going to be a minus 30 because I squared is negative 1. So then my answer here ends up being a negative 18 minus 46i. Okay? All right. Now, solving for complex roots. This problem here we can see is going to be complex because we don't have factors of 4 that add up to a negative 3, and so we're going to have some solutions that are complex. And the way we do a problem like this when it's not factorable, we're going to use the quadratic formula. So x is equal to 3 plus minus the square root of 9 minus 4 times 1 times 4 all over 2. And that's going to give me 3 plus minus the square root of 9 minus 16 over 2. And so going back up here, x is equal to 3 plus minus, I'll go I square root of 7 over 2, and there are our two answers. And the reason I have I there is because that's under the square root is a negative 7, but negative 1 is I. And so instead of having the negative under the root, I'm going to pull it out and call it I. Okay? All right. So going on to the next problem, this is number 9. When we divide by a fraction, we have to multiply by the reciprocal. And we need to factor 2. So these things look like they could be factorable. And so I'm going to go 5x minus 7 times 5x plus 7 over, what would that be? A difference of 1. 3x and x, and 2 and 7 go there. We need plus, so that would be positive, that would be negative. And then we need to reciprocate the other one, so I'm going to pull out a 4, I'm going to get x minus 2, and then 5x plus 7. Now, this will cancel with this. The x minus 2 and the x minus 2 will cancel, and our answer ends up being 4 times 5x minus 7 over 3x plus 7. The whole crux is to be able to factor these problems, right? That's the really, really important piece. And so make sure that when you do these problems that you are factoring. In this next example, we need to have common denominators. And so that's the trick to this problem. So I'm going to factor them and see what we can get. So 2 over 3x and x. So I'll go 2 and 4, and it's minus Ooh. Will that? Oh, cool. Hi. Chris? I'm already working out some of these problems, but if you would like to, if you have any questions or anything, you can go ahead and chat. If you don't have a speaker, you can chat and ask me questions on anything you might need. I'm recording this so that some of the problems that I'm doing, you guys can watch later on, okay? So I'm just working out this one problem right here. Actually, I'll start it over since you're here. It's actually great to have someone. Were you able to get this sheet off of the announcement page, Chris? Can you hear me now, Chris? Can you hear me? Well, all right. Well, I'll continue on. So in this example here on number 10, we're going to have to factor them. And so what's going to end up happening is I'll get 2 over, and then let's see if we can factor this. So 3x and x. So I think it'd be 4 and 2. So this should be minus and this should be a plus. And then this next problem is going to be 1 over, and then we need to factor it. So it's going to be 3x and x, and I need it to be 3 and 2, and they're both plus. And then to get common denominators for this problem, what I'm going to need to do is find the things that they have in common. So they both have this in common already. So what's not in common is going to have to be put and multiplied to the other. So this will be 2 times x plus 3. And the other one's going to be 1 times x minus 4. And then now we have a new whole denominator that has all 3 terms. So then from here, what's going to end up happening is I'm going to distribute. So I'm going to get 2x plus 6 plus x plus, ooh, that's a minus, minus 4 over the denominator. And so I'm going to end up with an answer of 3x plus 2 over 3x plus 2 x minus 4 x minus 3. But we can see that things cancel there, right? And so since things cancel, I'm going to get 1 over x minus 4 times x minus 3. And this is going to be my answer for this problem. Does that make sense? All right, cool. All right. Here's number 11. So for number 11, we can see we have a polynomial denominator on one side, and on the other side, we have 2 different terms. And I have a funny feeling that the 2 factors of the denominators on the right are what's going to be equal to the product of them will be equal to the denominator on the left. So this I'm going to rewrite as a factored piece, and I think it's going to be y and 3 and 2. And sure enough, it is what's on the other side. So then what I'm going to have to do is to get common denominators on the left-hand side, I'm going to go 1 times y minus 3, and then I have a plus 4 times y minus 2, and then that's going to have that new denominator that we want. Okay, So then from there, what we have is we're going to distribute. And we're going to distribute, and what we're going to end up getting is y minus 3 plus 4y minus 8 over that denominator. And now we don't really need to even worry about the denominator. What we need to worry about is the numerators. So the numerator of our original problem was 9, and we're going to go 5y minus 11. Okay? We no longer need to worry about the denominator. The only thing we need to really worry about the denominator is that y can't equal 2 and y can't equal 3. If we get either one of those answers, that's going to make this thing fail, right? Because it would make the denominator undefined. So I'm going to add 11 to both sides. So plus 11 and plus 11. And what that's going to give me is 20 is equal to 5y. So my y in this problem ends up being 4. Does that make sense? All right, cool. So that was number 11. So for number 12, actually number 12 is probably the hardest problem that's going to be on this test. It's all these worked out problems where we're working work problems together, right? Like one person paints a wall at a certain rate and another paints the wall at a certain rate, but together they do it in a certain amount of time. The whole crux to this problem is this. So it says working together, it takes 2 different size hoses 30 minutes to fill a pool. So basically every minute that passes, it's doing 1/30 of the work, right? For both hoses working together. Well, the bigger hose will do that 1 minute of work, but it will only fill up 1/50 of the pool, right? Because for every minute, it's only going to be doing 1/50 of the whole pool if it was doing it by itself. But working with the other hose, which we don't know what it is, it's going to do 1 minute worth of work, and then we need to find out how much time it's going to take for that one smaller hose to fill up the pool itself. So this ends up being the equation. This is the left-hand side is them working together, and the right-hand side is them as individual hoses trying to fill it. So then what I can do to make this problem easy is I'm going to multiply by a common denominator. And so I'll multiply by, what is that, 150x to everything. So I'm going to go, and I'll do it in a different color. I'll go 150x, and then 150x, and that's 1 over 30, and then it's 1 over 50 plus 1 over x. And so 150 divided by 30 is going to be 5. So I'm going to get 5x is equal to, and then 150x divided by 50 is 3x. And then this will be 150, right? Because 150x divided by x is just going to give us some constant number. So then subtracting 3x from both sides, what I'm going to get is 2x is equal to 150, so x will be equal to 75. So it should take the small hose 75 minutes to fill the pool on its own. Oh, that is terrible. Dang it. Whatever. It doesn't have to be perfect. That's the answer. Okay. Are you okay with that problem? Chris, can you hear me? It's coming through? It is?
Yes.
Okay, cool. I now I can hear you. I unmuted you.
Okay.
All right. So you can talk to me if you have questions. Just speak, okay?
Okay.
All right, cool. Here's number 13. I think what I'm going to do going forward too is at least once a week, I'm just going to hold live tutoring sessions for you guys so you guys can get help with whatever you need. Does this time work for you?
Yes, this works well for me, at least.
Okay. I'm going to try to do it 5 to 7. I may do it twice a week for other people, but I'll do this time for sure. Okay?
Sounds good.
All right. So now we're doing 13, and we're trying to solve this inequality. So, and this is the problem we're doing. So the first thing that I'm going to do is I'm going to move the 24 to the other side, and I'm going to get this. Okay, and so then I need to factor it, and when I go to factor this, I'm going to get x minus 12 and x plus 2, and that's going to be less than 0. Right? Now, to do this problem, I'm going to do a little grid over here. And the two numbers that we need that are important are negative 2 and 12. And do you know how I got negative 2 and 12?
From when you factored it?
Yeah, so what I'm doing is I'm factoring them, and then I'm solving each one for 0 to find its critical number.
Yes.
Okay, so then from there what I'm going to do is I'm going to go, all right, let's go x minus 12, x plus 2, and then both. And the one that matters to us for this is both, okay? That's the sign that's going to matter. So I'll do this in a different color. So if I pick a number smaller than negative 2, so let's say I picked like negative 3, and I plug negative 3 into this first one, am I going to get a positive number or a negative number?
A negative number?
Perfect, I'm going to get a negative number. Now, what about if I plug in negative 3 into the second one? Perfect. I'm going to get a negative number. That's all I care about. I care about their signs. Now, when they're multiplied together, though, what am I going to get there?
Negative or a positive.
A positive, right? So that's going to be a positive for both. And like I said, that's the one that's going to matter. So now in between, let's pick a number like 0, right? That's easy. So 0 minus 12 is going to give us a negative number, right? And then 0 plus 2 is going to give us a positive number, right?
Yes.
So then when they're both multiplied, that's going to give me a negative number. Right?
Yes.
Cool. Now on the positive side, if I go like 15, I'm going to get positive, and so I'm going to end up with positive, right? Because positive times positive is a positive. So the crux of this problem is the answer has to be what? No, the answer has to be negative. And here's why. Do you see here?
Yes.
The left-hand side has to be smaller than 0. And since the answer has to be smaller than 0, our interval, oops, change it to a pen, sorry. Our interval, because doesn't have an equal sign below it, it's parentheses, and I'm going to go from negative 2 to 12. Because that's where they both were negative. Does that make sense?
Yes.
Okay, so I should make that a positive in green so it's distinguished. So that's how you solve this type of problem. Since you got here a little bit late, this is what the actual exam will be like. It's just the numbers will be different. Okay, so if you really study this, I'm going to post this video on YouTube and then put a link on the announcements. So if you want to watch the first couple of ones that I did, you can watch them. But this is what the exam is going to look like for the midterm.
Okay.
All right, cool. Okay, so for this next one, we're multiplying them, and we have this cubic here. So let's deal with the cubic first. So this is going to stay the same. But this cubic power is going to change things, right? So negative 3 to the third, doesn't that become a negative 27?
Yes.
Yeah. And then x to the fourth raised to the third, if it's a power raised to a power, we multiply. So I'm going to get x to the 12th. And then 2 to the third, the 2 to the third power is going to multiply to become a 6. And then z is going to be to the third. Okay? And the reason they're showing this is that they're trying to confuse you for when you multiply and when you add.
Okay.
So negative 3 times a negative 27 is going to give me a positive 81 because negative and negative. And then the exponents here are just going to add. So my x to the third and x to the 12th is going to become x to the 15. My y to the third and my y to the 6th is going to become y to the 9th. And then z to the third and z to the third will become z to the 6th. And that's my answer for this one. Does that make sense?
Yes.
All right, cool. So it really is pretty straightforward, but some people can have a hard time with it. So I'm trying to make sure I cover it for you well. So this problem here, the way I like to do this problem is I think of it in parts. So that times then x to the 6th times my y to the 9th, y to the negative 4, and then z to the 2nd and z to the 7th. So 3 over 6 becomes 1/2, right?
Yes.
So now I'm going to do it this way. That's going to be a 2. The x to the negative 6, that makes it go to the denominator. So I'm going to have x to the 6th in the denominator. And then this y, right here, this denominator, y to the negative 4, it's going to go up and then become a positive, right?
Yes.
So then y to the 9th times y to the 4th, they're going to add, and I'm going to get y to the 13th. And the same thing with the z. That z to the 7th in the denominator is going to go up, and then it's going to add to the 2, so I'm going to get z to the 9th. Make that a little bit shorter. And this is my answer. Okay. Again, I want to show this to you so you can see. I also attach the answers here so you guys can see all the answers to these problems. And you can see, right, y to the 13th, z to the 9th, 2x to the 6th, that's that problem. And that's exactly what we got. All right, let's go back. Oh, did I do that right? Negative 12. Oh, you know what? I messed up on 13. Do you see it? I'm glad I actually checked the answer. I messed up. Look at this. Right here. Look at the factors. I mean, I explained the process right, but look at the factors. That last term, isn't that going to get me a negative 24? So the negative 12 times 2, doesn't that get me a negative 24?
Yeah.
And I'm supposed to get a positive. So let's do it. Let's redo that one and fix it. I'm glad I checked. I looked back there. I always tell my students in my lecture courses to never trust me. Especially my calculus students. I'm like, we're human. We make mistakes. And so you should always question the things that we show you. And there's a perfect example. So, okay, doing this again then, it should be x and x. And since I need it to be positive, it's going to be a -4 and a -6 that's less than 0. Okay? And then we'll go through that process again. But now it should be 4 and 6, right?
Yes.
So x minus 4, x minus 6, and then both. So that's negative, so that's going to be positive. If we plug in 5, 5 is going to give us a positive, a negative, so that's negative. And then bigger than that, they're going to both be positive. So our answer here is actually 4 to 6. Does that make sense? Or did I do that way too fast?
No, it makes sense.
Okay. So that's the answer to that one. Gosh, I'm glad I looked at the answer to show you. It's terrible. Okay. Can I move on to 16?
Yes.
Okay. So now with 16, I'll do it with long division so you can see it. And so I'll have 4x squared plus 15x plus 16 divided by this. So what I want is my divisor to have the same number in front. So that's got to be a 4. But I also want that x to be the same power. So what do I need to multiply x by to become x to the second?
The same thing.
So I have to multiply. So I got to multiply by x, right?
Yes.
So then 4x times x is going to give me 4x squared. Plus, then I have 4x times 2. And 4x times 2 is going to give me 8x. Now I got to take the parentheses of that and subtract it. And so we see the 4x squareds are going to cancel. But then I'm going to have 15x minus 8x. Right?
Yes.
Because of the minus sign. So that's going to give me 7x. And now I got to bring down my 16. So looking at this x here, I need it to become 7x. So what do I need to multiply the x by to make it 7x?
7?
Yeah, a positive 7, right? So I'm going to multiply by a positive 7. So 7 times x is 7x, plus 7 times 2 is 14. Parentheses subtract. And so the 7x is going to cancel. And what am I going to get as a remainder?
2.
That's right, 2. So my quotient is going to be 4x plus 7, and my remainder will be 2.
Okay.
I can't remember on Alex if it shows you synthetic.
What would that be?
Synthetic looks like this, so it probably doesn't. So it would look like this. I just take the numbers, I just take the numbers that are in front of the polynomial, and then I take the opposite sign of this number here. Since it's just x, I would go -2. So I'll show you, but don't worry about it. I'm just going to demonstrate it real quick. So that 4 would just come down, and then what's 4 times a -2?
-8.
Cool. And then what's 15 minus 8?
7.
Cool. What's -2 times 7?
-14.
And what's 16 minus 14?
2.
2. Okay, this was the x term, x squared term, the x term, and then a constant, right?
Okay.
So this becomes now 1 power less. So that becomes 4x plus 7 with a remainder of 2. See how that's the same answer?
Yeah.
Yeah, it's... I'm sure Alex just avoided it because they don't want you guys tripping on it. So I wouldn't worry about it. But if you ever go higher levels of mathematics, you'll definitely want to know synthetic. Okay, so this problem...
Easier, actually.
It is, right? It's actually, it is pretty easy once you understand it. Now, this problem here is a difference of cubics. And so cubics, their factorization looks like this. It's a minus b times a squared plus ab plus b squared. With my students, when I have a lecture class, it's usually same, opposite, always positive. I tell them it's SOAP. That's how you can remember the signs. So if it would have been like the positive case, right, it would have been a plus b, because it's the same sign. a squared minus opposite, and then always positive. Does that make sense?
Yes.
So in the example that we have, this is 5 cubed minus 3x cubed. Right?
Yes.
So that's going to give me 5 minus 3x, and then 5 squared. So it's now plus 5 times 3x plus 3x squared. So when we go to clean that up, it's going to be 5 minus 3x, 25 plus 15x plus 9x squared. And that's the factorization.
Okay.
Right? You've seen that formula before, right?
Yes.
Yeah, just something to memorize. Okay. All right, so for this problem here, it says 2 factory plants are making television panels. Yesterday, plant A produced 5,000 fewer panels than plant B. 5% of the panels from plant A and 2% of the panels from plant B were defective. How many did plant B produce if the 2 plants produced 1,010 defective panels? So to set this up, I'm going to do a little grid for us, okay? So I'm going to go plant A, plant B, and then a total. Okay, so this first block is going to be the number of panels. Good or bad or indifferent. Okay? So plant A did fewer TVs than plant B, right?
Yes.
So I'm going to call plant B X, and I'm going to call plant A X minus 5,000 because they made 5,000 less TVs. Okay? And then this next box is going to be the percent of defective. So the percent of defective is 5% for plant A and 2% for plant B. We okay?
Yes.
Now, this last one is going to be the number of defective panels. So the number of defective panels is going to be those two multiplied, okay? The number of panels and then the percent of defective panels. And I'll do it in a different color so it kind of shines. So 5% is the same as 0.05, right?
Yes.
And then times x minus 5,000. And then 0.02 is 2%, and that's going to be times 5,000. Now, the total number of defective TVs between the 2 plants was 1,010, correct?
Okay.
From both places, we got
Okay, yes.
we got that 1,010 defective TVs. So the equation to solve this is simply going to be this. It's going to be 0.05 times x minus 5,000 plus 0.02 times 5,000, and that's got to be equal to, that's got to be equal to our total number of defective TVs. Does that make sense?
Yes.
Cool. So then multiplying this out, I'm going to get 0.05x minus 250 plus 100 is equal to 1,010. So that should give us, yes. So then 0.05x minus 150 is equal to 1010. Adding 150 to the other side, I'm going to get 0.05x is equal to 1160, right?
Yes.
And then my x, and I'll write it down here, x is equal to 1160 divided by 0.05. And that is plant B made 23,200 TV panels. Okay? And let's see, what did it say? How many panels did plant B produce? Yeah, so 23,200 panels. Let's see if we're right. That was number 18. Okay, and 18 was, they got 18,000 panels. 18,000? Plant A produced let's see. I just want to make sure where we messed up. So plant A produced 5,000 fewer panels, so that's x minus 5,000. 5% of the panels from plant A and 2% of the panels from plant B were defective. Okay. Oh, I see where I messed up. Silly old me. Notice what I did. I can't believe I messed up. See my 0.2, 0.02, and 5,000?
Yeah.
That 5,000 shouldn't be 5,000. What's in the number of panels? Watch, I'll show you. What is this?
X.
It's X, but I put 5,000.
Okay.
So this should be, and this is where I messed up, that should have been 0.02x. So then that means that should be an x. Does that make sense?
Yes.
So sorry. So let's fix it. I bet you will get the right answer. 0.02x. My apologies. So I'm going to get 0.05x plus 0.02x is going to give me 0.07x minus 250 is 1010, right?
Okay.
So then 0.07x is equal to, is that 1260? Yeah, I believe so. Yeah, 1260. And then that divided by 0.07. So x is equal to 1260 divided by 0.07. That is 18,000. So it's funny, I wrote down the information, but then I just changed the number for some strange reason. You can see how these problems get tricky easy, right?
Yes.
But in fact, it's funny, I was going to tell you, the difficult problems here are number 12, number 18, and 19. The others are pretty straightforward. The word problems, right? They typically get people. Okay, so let's look at this next problem, the train problem. And the way I like to do this problem, I know probably Alex shows you charts and whatnot, but what I'm going to do instead is I'm going to draw a picture. So let's say that this is our train station, right? One train, so it's important for us to know this. North, south, east, and west, right?
Okay.
So in this problem it says that we have two trains, the one going eastbound, so the one going this way is going 95 miles per hour. So 95 times some variable x, correct? Our train going to the west is going 105 miles per hour, or times x, right?
Yes.
And what we want to find out is at what point will the two trains be when they're 560 miles apart. Does that make sense?
Yes.
Okay, so let's think of it like this. Every hour that the trains are they moving further away from each other or closer?
Further away.
Further away. And since they're moving further away from each other, every hour that passes or every moment that passes, their two distances are being added, and they're going to add up to 560 is the goal, right?
Yes. Yes.
So in order to solve this problem then, we're going to go 105x, because this is distance, right? Because it's rate times time, plus 95x, and then that's supposed to equal 560. Well, that's going to be 200x is equal to 560. So then x is equal to 560 divided by 200, and my x is 2.8 hours. So how much time is it going to take? 2.8 hours for the two trains to be some 560 miles apart.
Okay.
But the picture is what helps, right?
Yes. Yeah.
The picture is the big thing in this problem. All right. So let's do number 20. And I'll do that over here so I can have some space. So the first thing that I want to do with a problem that has fractions is get the heck rid of fractions. So what's the number that goes into both 2 and into 3 that they multiply and get?
6.
6. So I'm going to multiply everything by 6. Okay?
Okay.
So what is 6 times a negative 1/2?
3.
It's going to be a negative 3.
Negative 3.
Negative 3, right?
Yes.
Okay. And then what's 6 divided by 2?
3.
And then times 7?
21.
21. So that's how I got this number, because that's 6 times this number right here. First I'm going to divide, and then what's left over I'm going to multiply by the numerator. That's the trick. And then I have a y there, so what's 6 times y is 6y, right?
Yes.
And then minus, we're doing this problem now, 6 divided by 3,
2.
and then times 7.
14.
Perfect. And now we've gotten rid of our fractions.
Okay.
So now what I'm going to do is I'm going to add 3y here. So I'm going to add 3y over here. And so I'm going to get negative 21 is equal to 9y minus 14. And then I'm going to add 14 here. So I'm going to add 14 there. So I'm going to get 9y is equal to, it looks like a negative 7. And so y is equal to a negative 7 over 9. And that was 20. Let me just check the answer, okay? Negative 7 over 9. And cool. Like I said, don't ever trust me. All right. So that was number 20. Here's 21. So for this problem, the first thing I'm going to do is I'm going to distribute. So I'm going to get 7y minus 32 is equal to a negative 18 plus 14y. Right?
Is it going to be equal to or less than?
Ooh,
Does that matter?
yeah, it does matter actually. Thank you. It should be less than. I can't just change the operation. Thank you. All right, now from here then, I'm going to, first off, I'm going to subtract 7y. I'm going to subtract 7y, so I'm going to end up with a negative 32 less than 18 plus 7y, right?
Yes.
Then I'm going to add 18 and add 18. And so I'm going to have 7y, and what's that going to be? 14? A negative 14? So then dividing by 7, I'm going to get a negative 2. So negative 2 is less than y. Right?
Yes.
Now, when do I flip the inequality?
Whenever it's a negative?
Whenever I multiply or divide by a negative. So
Okay.
if that 7 right there would have been negative, I would have had to have flipped the inequality. So if I would have had something like this, when I divided, I would have had to flip it
Okay.
and then gone that way.
Okay.
Right? That's when you
Yes.
multiply or divide by a negative, you flip the inequality. Okay? Cool. All right, number 22. Now, when we're dealing with absolute value like this, you want to have the absolute value by itself before you try to solve the problem. Okay? So that means I got to get this guy to the other side, right?
Yes.
So that means I got to add 63 here, so I got to add 63 there. So I'm going to get the absolute value of 6v plus 6 is going to be equal to negative 15 plus 63. That's going to be 48. Okay? And now from here, we need to treat this as two problems. So I'm going to get 6v plus 6 is equal to 48. Or 6v plus 6 is equal to a negative 48. Because whenever you have absolute value, you need to check for two possible answers, okay? So then subtracting 6 from here and subtracting 6 from here, I'm going to get 6v is equal to 42. So v should be equal to 7, right?
Yes.
All right. In this example here, I'm going to subtract 6 and I'm going to subtract 6. So I'm going to get 6v is equal to a negative 54. And so my v is going to be is that a negative 9? Right?
Yes.
Okay, so now what we want to do at this point is we got to check both of them to see if they're going to work. So 6 times 7, just plugging into here, 6 times 7 is 42. Plus 6 is 48, right?
Yes.
What's the absolute value of 48?
48.
It's 48. So then 48 minus 63 is a negative 15. So we know that this one works. So for sure, we know that works. Okay?
Okay.
Now let's try negative 9. 6 times a negative 9 is a negative 54. Right?
Yes.
Plus 6 is a negative 48. What's the absolute value of negative 48?
48.
And 48 minus 63 is a negative 15. So both work.
Okay.
But you have to check both when doing these problems. Okay?
Okay. Okay.
All right. And then 23. This is the last problem on this practice exam. And then what I'll do is I'll stop recording. But if you have any questions for me, I'll just answer any questions you have. Or I can go over the first examples that I did. Okay?
Okay. Okay. So good.
All right. So looking at this problem right here, we're going to break it up. Because it's absolute value, we have to treat it as two problems. The first one is, and I'll actually write it where I have enough space to work, where there's no change. Okay? No change at all. and then solve it. So I'm going to add 3 to both sides, right?
Yes.
And so v is going to be greater than or equal to 7. So that tells me it's a filled in circle at 7, and then I'm going to go in this direction, right?
Yes.
Okay. Then the other one is where we do make change, and that is I'm going to get absolute value of v minus 3. The absolute value is dropped. I have to flip the inequality and then change the 4 to a negative.
Okay.
And then I got to do solving it like I normally would, right? Add 3, and so I'm going to get v is less than or equal to a negative 1. You agree?
Yes.
So then filled in circle, right? It's not an open circle. And then we're going this way.
Okay.
Got it? All right, let's make sure that we got it right. And 7 and negative 1, and we got it right. Cool?
Yes.
All right, that is the 23 problems for the practice exam. I hope you guys found it beneficial, and let me stop the recording.